Hello and welcome back, everyone. I hope you guys are making great progress with cracking these algorithms. And here I come too with a little help, and I'll show you how to solve a very cool problem, daily temperatures. Let's first understand the problem and let's understand all the requirements. So we're given an array of integers, which is called temperatures, which represents the daily temperatures. And we're asked to return an array answer such that answer of I is the number of days we had to wait to get a warmer temperature. So if there's no such thing, we'll just keep answer of I equal to 0. So think about this. This is the first day, this is the last day. So at this particular day, how many days we had to wait to get a warmer temperature? So this is 73 Fahrenheit, just for everyone outside of the US, these are Fahrenheit degrees. So we have 73, and then the next day we have 74. So then we had to wait only one single day, right? So that's why we're populating answer of 0, in this case, to 1. But let's look in this example. In this example, how many days we had to wait? So if we're looking right, how many days we had to wait to get a warmer temperature than 75? So we see that in order to get to 76, we had to wait 4 days. So that's why we're populating 4 right here. But there's a third scenario. If we're looking at this specific situation, how many days we had to wait to get a warmer temperature? So there's no warmer temperature. So that's why we're going to keep this as 0, and the same for the last case, we're going to keep this as 0 because there's no warmer temperature that comes next. So I hope that made sense, but now comes the question, how would we approach this problem? So let's move to our whiteboard right here and let's think about what would be our first thought when we would see this problem. And now I have two words for you, and these are probably my favorite words, and these are brute force. Brute force, I love these two words. So think about brute force. What would be the brute force for this problem? And I also recommend you to always come up with a brute force solution for any problem out there. Even though if you're not start to code that problem, just walk the interviewer through the brute force approach. So in this case, it's quite simple probably, right? We would look at this day and we know that we have to find a warmer temperature that comes next, right? So once we find it, the first one, we're just gonna subtract the index. So this index, we're gonna get the difference. So in this case, 1 minus 0 is 1. And then we're moving to the second day, and then we're gonna look all the way here, and then again 2 minus 1 1, and then we're moving to this day, and in this day 75 we're looking all the way here, and then we see the next greater element is at 76, so 6 minus 2 4, and so on, right? So this would probably solve this problem, and it will be probably okay. The only drawback that I could think about it is it will take a lot of time, right? The temperatures array could get very big. It could get 10 to the 5th, I think. That's specified in the Leetcode, so it could take a lot of time. So how would we optimize this? How would we optimize this solution? So probably you see this little thing right here, stack. So probably you already have an idea. So we're gonna use a stack for this problem. And we're gonna add some space complexity indeed, but we're gonna improve our time complexity. So we're just gonna be able to do this problem in O of n. So we're only gonna traverse this array only once. So I think most of the interviewers would be probably pretty satisfied with this solution. So let's go ahead and think about how would we do this problem with a stack. So the reason why I'm choosing to use a stack is because if we're looking at this numbers right here, 73, 74, 75, and so on, all we have to do is find the greatest one. And once we found the greatest one, all we have to do is just compute the differences between the indices. But in our stack, in this example, we're not going to add the temperatures, but we're going to add the indices directly in our stack because it will be easier to compute the difference. So let's walk through an example. So we'll have a for loop. We'll start with I equal to 0. So we're gonna add this element into our stack first, and don't worry about the code. Code is very short, so you will see it will probably make a lot of sense when you will see the code too. But I'm just gonna walk you through like dry run through a little example so you understand it better. So we have this, we're starting from here. We're gonna add this to our stack. And then we're gonna go ahead and we're gonna move to 1, just because this is gonna be our first comparison. So I is equal to 1 right now, and our stack contains 0. So we need to find out if temperatures of stack.peak, which is temperatures of 0, which is 73, if that's smaller than temperatures of I is 74. So that's the case. So if that's the case, we know that we found a greater one, so we need to compute the difference. But before computing the difference, let's pop this element from our stack and let's keep it into a variable. Let's call it last, and this will be equal to 0. And now we are going to populate our array. So I, which is this one right here, minus whatever we had in our stack, which is this one. So we'll have I minus last. So this is exactly what we need to populate in our array. So result of last, result of 0 will be equal to 1. And then we're moving ahead, we're doing exactly the same thing, and then we're pushing, after we populate this array element, we're pushing our I into our stack. So right now our stack contains 1. And then we're doing exactly the same thing. We're making exactly the same comparison again. So right now our stack.peak, which is 1, so temperatures of that is 74. Is this 74 less than our I is equal to 2 now? Then 75, yeah, that's great. Our last is 1. We're removing it from the stack. And then our answer of 1 is going to be equal to 2 minus 1, which is still 1. Now comes the interesting part. So we're pushing into our stack, we're pushing the value of our I, so 2. And right now our I changes to 3. So right now we're doing exactly the same comparison, right? So we're comparing 75, which is stack.peak right here, temperatures of stack.peak. Is this less than temperatures of I, which is 71? So that's not, right? So if it's not, it means that we didn't find it. So we're not gonna pop anything from the stack, but we're just gonna keep going. We're gonna add this to our stack and we're just gonna keep going. So right now we're adding this to our stack and then we're just gonna keep going. So now is I is equal to 4. Probably I needed a few more right here. I is equal to 4. So we're all the way here, right? So if I is equal to 4, let's do exactly the same comparison. So we're at 75 right here. We're at 71 right here. Stack.peak is 3, this one. And I want to find out if it's less than temperatures of I, which is 69. So it's not, so we're going to keep going again. So we're going to add 4 right here to my stack too. And now I'm going to move to I is equal to 5. And this is how it will work right now. So in my stack, I have 4, so 69. Is it less than temperatures of 5, 72? It is, right? So right now I'm going to pop it from the stack. So I'm going to pop 4 from the stack, right? I'm going to, my last variable will be called right now, will be 4. And then my answer of 4, so this case right here, it will be equal to I minus last, right? So 5 minus 4, 5 minus 4 is equal to 1. So I'm gonna populate this to 1. So now it means that I need to do this whole thing in a while loop, while the condition would be temperatures of stack.peak is less than temperatures of I. Because right now I'm gonna start populating the next elements, because my conditions might have changed. You see right now 72, which is temperatures of I, and I popped this from the stack, so stack that peak is 71. So 71 right here is less than 72. So I can go ahead and populate this element and so on. So I hope that made sense, but let's go through the code and let's see how the code would look like, and I'm sure it will make much more even sense. It's, as I said, it's not too lengthy, but let's just go ahead and code this problem. So we said we need a stack, right, which will contain integers, and we'll just call it stack. Right, so we also need to, let's get a variable for the temperature's length, so I'm just gonna call it n. Cool. And then we need to create a answer array, right? So I'll create an answer array. Answer is equal to new int, and is gonna be equal to n. And then what we have to do right now is we're going, in our for loop, we're gonna go through all of those elements, right? So we're gonna have I is equal to 0, I is less than n, I plus plus. And right now, before we even push the element, we need to check if we can pop any elements. So this is what I said, we're gonna have all those sets of conditions in a while loop. So while my stack is not empty, first of all, right? Because if my stack is empty, I can get pop any elements, I'll get an exception, right? So if my stack is not empty, right? And now here comes our condition, and temperatures, I'll just copy so I make sure I don't have any misspellings. So temperatures of stack that peak, so whatever element I have in my stack right now, it is less than temperatures of I. So if that's the case, all I have to do right now is get a variable. I said we'll call it last, and it will be stack.pop. So we're removing the element, whatever we have in our stack, and then we're gonna calculate the difference, and we're gonna populate our array. So our answer of last is gonna be equal to I minus last, the differences between the indices, right? And after we've done all this, we're just gonna go ahead and we're gonna push our I into our stack. And that's pretty much it. All we have to do is just return our answer array. So that's pretty much it. This will probably do good for this problem. Let's give it a try. Accepted, so let's submit it. Yeah, so it seems like it's working fine. This is a cool problem just because it introduces this concept of monotonic stack. I'll make sure that I'll make more problems which are very similar to this, so you can even get the concept even better. That's it for this video. I hope you guys like this video, and whenever you'll encounter a similar problem, just remember how we solved this and you will do great. And one ask, if it's not too much to ask, a simple like would be super appreciated. And that will also work for you because it will give you a lot of suggestions on your YouTube feed. So the more you surround yourself with topics like this, the closer you will be to master all of these. Until next video, I hope you'll have a wonderful week, and don't forget, for any problem out there, we have plenty of solutions. I just didn't realize that sounds pretty philosophical, but I guess it's true not only for coding. But anyway, see you in the next video.